Now we're going to sidestep a little bit. Notice that the motion diagram, it looks a little bit different now. Notice that we actually do have our velocity over here over time, and now we actually do have our velocity changing. Before, our velocity was just constant, it just moved horizontally. Now we actually do have it changing. Okay, so we're just going to do the same thing that we did before. We're going to find the slope of this velocity over time graph, and we're just going to go from there. All right, so we have these numbers should make sense to you considering what we've learned in the past. And so this is equal to 6 over 1. And our units is meters per second per second. So meters per second per second. And usually I do write the SEC. Okay, so what is this actually telling us here? What do these units actually mean? So this is basically saying for every second, the object's velocity changes by 6 meters per second. Okay, so this is saying, once again, let me just reread this. For every 1 second, the object's velocity changes by 6 meters per second. What this is basically describing to us is actually an acceleration. An acceleration is a change in velocity over a certain amount of time. Now, let me ask you this. When you are in the car with somebody and you're thinking to yourself, hey, you know what? This person's going a little too slow. He needs to speed up. How do you actually go about saying that? You basically say to them, hey, you need to accelerate. And basically what you're saying is you need to change your velocity. You need to go faster in a quick amount of time. And that's basically what you're saying. Hey, in acceleration, you need to accelerate. Or you could actually say to yourself, hey, you know what? I think that my friend's going a little too fast right now considering the speed limit and they need to slow down. How do you go about saying that? Oh, you need to decelerate. You need to go slower. And that's what you're doing. You're changing your velocity over a certain amount of time. Now, once again, what I'm actually just going to do right now is looking at this. I'm just going to rewrite this. So what does this 8 represent? Oh, that is our final velocity. What does the 2 represent? Oh, that's our initial velocity. Divided by, once again, I'm just going to write here, instead of final time minus initial time, I'm just going to represent that using our delta t. And this is our formula for acceleration.